Hi all, hope you are all fine. So in the previous tutorial we had a discussion on LR parsers and I got a lot of queries regarding the computation of LR0 automation. So this tutorial is for that. So let us see an example. So this is a grammar for which we have to construct the LR0 automation. S giving L equal to R, S giving R, L giving star R, L giving ID and R giving L. Now what is the first step? We have to create augmented grammar from this given grammar. So how will we construct augmented grammar? First we have to identify the start symbol. So here the start symbol is S. Then we have to add an additional production S dash giving S. So here I have added that S dash giving S and remaining all productions are similar to our given grammar. Okay, only added production is S dash giving S. So thus we will get the augmented grammar. Okay, so if in where most of the questions they will not provide augmented grammar, they will only give the grammar. So first step is to create the augmented grammar. Now what is the next step? We have to create LR0 item. Okay, so what is an item? An item is when we add a dot symbol at the end of this productions, at the left hand side of this productions. Okay, first we have to take a production, consider its RHS and put a dot at the left end. Thus we will get an item. So this was discussed in detail in the last tutorial. So in this example, let us see how to construct LR0. Okay, now I am going to name the first set as I0. So first I am adding the production S dash giving dot S. This is my first LR0 item. Okay, the first production I have added dot at the left end. What's the significance of this dot? Means the parser has traversed till the dot. So at the beginning at the left end is the dot, so it means that the rest of this production on this mean the string in the right hand side of this dot operator, parser haven't seen any of that string, only till dot it has seen the string. So at the beginning it has been traversed the string. That is the significance of dot. Now see, I am adding LR0 item as S dash giving dot S. Now, whenever we have a non-terminal symbol at the right side of the dot operator, keep in mind, whenever we have a non-terminal symbol at the right of dot operator, we have to include that productions in the item. That is known as the closure. Okay, that is called closure of item. So I have S here after dot. So what I have to do, I have to include the productions starting with S. So I have to include S giving dot L equal to R and S giving dot R. Now again check here after dot I have capital L. So what I have to do, I have to include the productions with capital L. So I have to include L giving dot star R and L giving dot ID. Again I have here capital R after dot. So I have to include the productions R giving dot L. Okay, so this is called closure. Okay, so whenever I have a non-terminal symbol at the right end of the dot operator, when we have an item, then we have to include the productions with the dot at the left side, and this is called closure operation. This is called closure. So this set I am naming it as I0. So whenever we compute the closure, I have to compute the goto operation. So what is goto operation is when we move the dot operator one element to the right. whether it is a non-terminal symbol or whether it is a terminal symbol, it doesn't matter. Whenever I move this dot on symbol to right, in which state I will go, that is known as goto. Okay, so let us find the goto of this I0 one by one. Now the first prediction is S dash giving dot S. So I am going to shift the dot operator one to the right. So what will I get? I will get S dash giving S dot. And how I am shifting? Through S. That is why I am giving S. Okay. So I will get S giving S dot. Now if after this dot operator there are no symbols, so I don't have a to include closure. Okay, only this is in the set I1. I am naming it as I1. Now after S I have to traverse through capital L. If I am moving this dot one position to the right through L, I have two productions, this one and this one. So I should include these two productions in one set, because by traversing through L, I will get these two productions. Okay. So what will I get? S giving L dot equal to R and R giving L dot. These two productions I will get. Now check here. I have dot operator here, and the next to dot operator I have a terminal symbol. So I don't have to include closure. Here after dot operator there are no symbols. So this set is complete. I don't have to include any closure here. So I'm going to name it as I2. Now after this I'm going to move this dot operator one point to right of capital R, and what will I get? I will get R dot. Okay, and I am naming it as I3. Similarly, if I move one point to right of ID, I will get L giving ID dot, and I am giving it name I5. So these are all non-terminals, and this is terminal. We have one more terminal here, that is star. Okay, that also we have to consider while finding goto operation. So if I move this dot operator one point right of star, I will get L giving star dot capital R. Okay, now since there is a non-terminal symbol at the right of dot operation, I should include the closure. Okay, so R giving dot L is included, L giving dot star R and L giving dot ID are included. This was included because right side of dot operator there was capital R. These two were included because right side of dot operator there was capital L. This way we computed goto of I0. Okay, from I0 on S we get I1, from I0 on L we get I2, I0 on R we get I3, I0 on star I get I4, and I0 on ID I get I5. Similarly, we have to compute the closure and goto of remaining sets. Now see, for I1 there is no symbol after dot. That means it is terminated. I hope you remember that kernel and non-kernel items. So there is a no go to operation from I1. Now case of I3 also there is no further go to operation. Case of I5 also no go to operation. Now remaining is for I2 and I4, because we can still move dot operator, right? So we will see. So for I2, if I move dot operation of dot operator one point to the right, what will I get? As giving L equal to dot R. Again we have a dot of after dot operator have an on terminal, so I am including the closure. Okay. And for this production, I can't have a go to operation because dot operator is at the end. So for equal to only I have go to. Similarly, for so I am naming it as I6. So similarly for I4, for R, if I move the dot operator over R, I will get L giving star R dot, and I am naming it as I7. So what's the next thing? I can move it over L, right? So if I move it over L, I will get R giving L dot. Further closure is not possible as dot is at the end. Similarly, if I move this dot operator one point to the right of star, I will get L giving star dot R. See, L giving star dot R is I4, right? We'll get the same set. So what will we give? We will give the arrow as a loop. Okay, for star, it's the same I4 we will get. Now, if I move I for ID dot operator over ID, I will have an arrow to I5. Okay, so for I2 and I3, we computed goto function. Now, we can compute goto for I6. For I7 and I8, I cannot compute. So next for we will compute. So this I6 I am showing by red. On I6 on capital R, that is if I move the dot operator one to the right, I will get this production. No more productions because dot is at the end. Similarly, on if I move this on right to the L, I will get I8. Similarly, if I move to right of R, I will go for I4. Okay, over star. Then if I go to move this on ID, on point right of ID, I will get I5. So this is our LR0 automation. Okay, we got a DFA. Okay, for this items. So first we compute set of item. From that set, after getting this closure, we will compute go to. From that sets, we will again compute go to till no more possibilities are there. In every set, we have dot at the end. Till that, we have to compute the go to. So hope you are clear with this. Watching.